This conference will now be recorded.
Okay guys, let us start today's session. So in our last class, we completed learning about the non-recursive in-order traversal, where initially we have learned theoretical English-like language type of algorithm, and then we converted to into the corresponding C coding. Sir, it's very simple, sir. How? Sir, I will start from the root node that is pointed by PTR. And now I will start moving towards left. On this way, whatever nodes will be there, I will put them into the stack. So who will be there first into the stack? A. Next B. Then how long you will do this kind of thing? Sir, until I reach to the leftmost node. But I will make sure, sir, leftmost node I will not put into the stack. So currently, where is your pointer pointing? I reach to the leftmost node. There my pointer is pointing. And in the stack, what you are having? Sir, in the stack, we are having A followed by B. At the bottom of the stack, I am having A. And then on top of that, I am having B. So currently, where you are standing? Sir, here. That means I have reached to the leftmost node. Generate code for that. Very simple, sir. Writing code for that. What is that? Sir, at the outside, I have an infinite loop. Later, we will decide why this infinite loop we are having. Currently, I am focusing here, sir. What is that? As long as PTR arrow L child is not equal to null, push PTR. Sir, A got pushed. PTR is pointing to B. Loop rotates. B arrow L child not equal to null. Yes, sir. B arrow L child is D, not equal to null. Push that B into the stack. PTR equal to PTR arrow L child. PTR comes to where? D. Then PTR arrow L child not equal to null. No, sir. D arrow L child is basically null. Don't push. This while loop is done. And my PTR is pointing to where? D. Now what I will check, sir? So as per this English word, step 1 to done. Now I will check where that PTR is pointing. I will check that, sir. Is it having any right subtree or not? If it is not having any right subtree, I will feel very happy, sir, because I will visit that node. So currently it is not having any right subtree, so I will visit that node. Then who will be visited? D. Then what else I have to do? Sir, 100 to 100% I have to look into the stack. Now once you look into the stack, what you are getting? Sir, I will get B here, because first B, next A. B I will get it. Then what you will do? Sir, if the stack is empty, sir, then automatically I will say that the traversal is finished. But currently stack is not empty, because in stack I am having at the bottom B, and on top of that A is there. Now what I will do, sir? Sir, I will keep on popping and visiting the nodes. Keep on popping and visiting. How long you will do this popping and visiting? Sir, until I get a node which I pop, but which is having a right subtree. Sir, one more time. Sir, now my objective is keep on popping and visiting the node. Are how long you will keep on popping and visiting? Sir, until I pop a node which is having a right subtree. But immediately you got a node which is having a right subtree, then what you will do? I will stop there. I will stop there. Let us implement this into the coding. So currently I'm checking PTR arrow arch child. Where is PTR? D. Is it equal to null? Yes, it is equal to null. Means what? It is not having any right subtree. I visited. If stack is empty, algorithm finished. No, not empty. Then what I do? Sir, pop. I said, na, keep on popping and visiting. So here it is pop. Again, this is visit. This is pop. This is visit. So this will be in a loop only, sir. So now I pop one item from the stack. Who is that? B. But B is having, you said na, keep on popping and visiting. How long? Until you get a node which is having a right subtree. Now currently you got a node which is having a right subtree. Why, sir? PTR arrow R child, B arrow R child is equal to null. No, not equal to null. This condition is not true. That means what? B is having a right subtree. And what immediately will say? Sir, visit B and move to the right child. So that means this is done and this is also done. So just now what you visited? Sir, visit B and move to the right child. So till now how many nodes visited? Sir, till now D visited and B visited, and currently you came where? Right of B. Currently you came where? Right of B. That means it is pointing here. Your traversal finished? No. Again I have to do the same thing. Initially I assume that it start PTR is rooted at A. Now instead of PTR rooted at A, now PTR reaches here. But my activity will remain same. That is why what I did here, I kept the entire thing inside a infinite loop. I kept the entire thing inside a infinite loop. Why? Because, sir, I don't know when to stop. Can you tell me after 5 iteration, after 6 iteration, after 10 iteration, it will be stopped? No, sir, I don't know when it will be stopped. That's why I kept the entire thing in this while one loop. Now from where it will start, sir? It will start from E. What it will do? Same thing, sir. Remember currently who is there in the stack? A is left. Now from here again you will start doing what? Sir, keep on moving on left hand side. And on this path everything I will be pushed. First I pushed E. First I will push E. But should I push E, sir? No. Why? Sir, it says keep on. It says that move along the leftmost path and push all the nodes until you reach a leftmost node. That leftmost node should not be pushed. But sir, I'm in such a node which is basically a leftmost node. How do you know that it is a leftmost node? Because sir, this node is not having any left child. This is definitely leftmost node. So am I going to push that E into the stack? No. So that means this part again done. While PTR or L child not equal to null, no is equal to null. Will you enter? No, I will not enter. Will you push E? No, I will not push. Not push E. Now what we are checking? For that E, do you have any right subtree? No, I don't have right subtree. Then PTR or R child equal to null. True. Not having right subtree. Visit that. Stack becomes empty. No. A is there in the stack. I remember, sir. So just now you visited which one? E. So till now you visited what? D, B, E. I think further telling the story not required, guys. Now you will understand now, or further I need to continue? You got it clear now? English language conversion to this coding. Is it okay, guys? Or you are expecting, sir, few more minutes continue with that DBE? Tell me once in the chat box if you feel that, sir, continue, or is it okay, sir? DBE up to this is done. I need to continue, guys, or is it okay? Respond in the chat box, students. Sir, now PTR is equal to pop is A, definitely. Now where I am? Here, PTR is equal to pop is A. Okay, let us move for another few nodes. PTR is equal to pop means A, correct? Now keep on popping and visiting until you pop a node which is having a right subtree. So just now you pop a node which is A and you find that see, A is having a right subtree. A is having a right subtree. So that means what? PTR arrow R child, A arrow right child equal to null? No, not null. Not null. Don't enter, write PTR arrow data. Who will be printed, guys? A will be printed. So D, B, E, A. What do you say, guys? D, B, E, A. Currently PTR is here. Let us move further. PTR equal to PTR arrow R child. Where PTR came? Where PTR came? Here. Again do the same activity. Now, sir, the activity that, sorry, not here. Though basically same. Again do the same activity. Now, sir, what you have done by starting at A, Then doing the same activity by starting at E. Same activity I'm going to do it again now. Yes. Tell me, student, further require or you are happy with A, sir? Remaining things I will manage. Or I should go for the remaining 3 also. Tell me. Yes, sir, clear. So now can I go for code implementation? Yes. This is our code. Non-recursive pre-done. Non-recursive in, sir. So in that non-recursive in, currently what we have receiving? Sir, we are receiving the root node's address in the variable ptr. Then what we will do? Sir, again one more time, story, and we will do. What we will do? Sir, move along the leftmost path while ptr arrow l child. Ptr arrow l child not is equal to null. What I should do, sir? Push into the stack. Push ptr. And then ptr equal to ptr arrow l child. Tell me, guys, sir, when the loop will be terminated, when the loop is finished, you will be standing outside of the loop. So as per our first diagram, at this point, can you remember the value and can you tell me ptr is pointing to where now? From the diagram, can you tell me ptr is pointing to where now? I will not show you the diagram. Good. Sir, ptr is pointing to D. As per our diagram, ptr is pointing to D. Very, very good. Now what I will do? Sir, keep on popping and visiting. Of course, I will keep on popping and visiting, but before that, currently ptr is pointing to Duna, sir, pointing to Dina. I will check whether it is having any right subtree or not. Of course, it is not having any right subtree. So I should visit that node. How to visit that node? Printf %d ptr arrow data. Why you are visiting this node? Because it is not having the right subtree. Now what they said? Keep on popping and visiting. But before keep on popping and visiting, they said that check it out if the stack is empty or not. How to check stack is empty or not? Sir, if top is equal to -1, that is stack is empty, then what I will do? Nothing to do, return. Otherwise, keep on popping and visiting. Pop. I made a pop operation. Can you remember in the stack now who is there? Or can you remember who will be pop? Who will be pop from the stack? Can you tell me? Good. B will be pop. I'm capturing that B in the PTR. Very, very good. I'm capturing that B in the PTR. Next, what I will do, sir? I will check again the element that I pop, whether it is having a right subtree or not. It is having a right subtree, I will be stopping there. So what I will do here, I'm keeping this thing inside a loop. What is that? ptr arrow art child is equal to null. Means what? Not having right subtree. Now you see, currently ptr value received what? B. Loop rotate, sir. B arrow art child, is it equal to null? No. B is having a right subtree, so it will not enter here. Then what it will do? Sir, visit D. Print a %d ptr arrow data. Then move to where? B is having right subtree means move to its right. What to do? ptr is equal to ptr arrow art child. Tell me currently ptr is pointing to where? Super. E. Sir, now from the standing at E, I have to do the same activity. What you have done? I have done this activity. The same activity I will do again, sir. Then keep this inside a infinite loop. Keep this same thing inside a infinite loop. Super na boss. 1 minute, let me indent properly. Loop rotates. Come here. Sir, now from E I will start. Or E don't have any left child, sir. That is the leftmost node. Okay, then no question of pushing. E or L child is not equal to null, no equal to null. Should I push? No. PTR is currently pointing to where, sir? E. Now E is having right subtree? No. Then enter. If it is right subtree, you will have stop. You have to stop. E is having right subtree? No. Enter. PTR arrow data. Who is visited? E is visited. So till now, which nodes have been visited? Sir, D got visited, B got visited, now E got visited. Remember, D, B, E. Stack empty, no. Who is there in stack, guys? When I will make pop now, what I will get? What I will get from stack? Tell me what I will get from stack. A. Good. Loop rotates. A is having a right subtree, na? Yes. Then stop. PTR or archive is equal to null? No, not null. Visit that. What is visited? A. So till now, which nodes are visited, sir? I'm just writing here. D visited, B visited, E visited, A visited. Sir, A got visited. Now, currently, who is there in this stack, sir? Acha, A got visited where? Here. Sorry, not in the loop, here. A got visited here. Because A is having a right subtree. PTR equal to PTR or R child. Tell me, PTR will be going to where? C. Now, after this, I didn't explain. Okay, I got the code here. Let me go for it. What is the problem? C. Now C, I will start from C, same activity. Sir, from C, I will go to the left in the left direction, and on this path, every node I will push into the stack except the leftmost node. Is C is the leftmost node? No. PTR or L child not equal to null, na? Yes. Push. Remember, in the stack, who get pushed? C. Remember this. PTR or L child, sir, that is F. PTR or L child means F. Okay. F arrow L child not equal to null? No, not null. Sorry, F arrow L child not equal to null? No, null. Don't push. Don't push. So PTR is now pointing to where? F. Stack C. Now what you will check? Sir, F is having right subtree or not? PTR arrow R child is equal to null, na? No right subtree. Visit PTR arrow data. Who got visited? F. Super. Is stack is empty? No. Pop. Who will be pop? Who will be pop from the stack? C. Done. Come back here. C is having a right subtree, guys. So stop and don't enter. C arrow L child equal to null? No, not null. C is having a right child, na? Not null. Don't enter. Outside of the loop. Printf PTR arrow data. Super. C. PTR is equal to PTR arrow R child. That means C to G. Then do the same activity that you have done for A, that you have done for E, that you have done for C. Same thing you start from G. But G is leftmost node, sir. Then no question of traversing towards left because it itself is the leftmost node. Is this loop will entertain? No. PTR is currently pointing to where? G. What is there in the stack? Currently nothing is there in the stack. Now for G, will it have any right subtree? No, sir. Equal to null is true. Visit that. Visited. Stack empty na? Yes. Directly return from here. Where? To the caller. Who is the caller? Here. Break. Menu reappears. Execute guys, compile and run. No error, no warning. And acha, I need those values now. 1 minute. I think guys, 2 or 3 times you need to practice by saying what you are doing, not by in your mind. You will find that, oh, it's very easy. Aniket previously were telling last class, sir, recursive function, how we can become efficient of that. Whenever you are practicing any non-recursive program or problem, just sit in front of the machine and loudly say what you are doing and listen that. I'm doing it, then this is happening, like loudly you say and then practice. Then automatically your mind will be set up for thinking recursively and how to work recursively. Otherwise, if you always sit in front of the machine, practice, but never listen, never shouting and never listening, then your mind will not grow, your mind will not be synchronized with that recursion. Recursion is such a thing, na sir, where my mind have to be synchronized, and the mind will be synchronized with recursion only if you are telling what is the thing that is happening and listening also. That 2 time, 3 time, 4 time you will done, then you will find that your mind got synchronized with recursion. That is how synchronized, that is how recursive program you have to practice. Then automatically new problem, na, your mind will automatically synchronize with recursion. Now it will tempt you to go for recursive thinking. Otherwise, just in your mind, never saying anything, if you practice, what will happen? New problem will come. Your mind will not be, your mind is not synchronized, so it will not tempt you to think in a recursive way. That is how you have to practice. Okay, sir. So enter your choice. Let me. Achha, you have this. Oh, in order traversal. Even if you don't have, I don't care, because sir, it will be giving us sorted order. Enter your choice. 150, 30, 60, 22, 38, then 55. Next 34. Yes. Now what I want, in order traversal. Non-recursively, we are doing in order traversal. What it will give, sir? We know that sorted order only, na? Enter your choice. Achha, I need to give that spaces, guys. No problem. But let us check this sorted order is coming or not. 22, 30, 34, 38, 50, 55, 60. Means what? Sir, our algorithm is perfectly okay. Or you can go for /t also. Here also /t I used yesterday. Yeah, that is non-recursive or iterative pre-post, pre and in. Last one, sir. Post-order traversal, right? So what I will do, I will make a calling from here. Enric post. Okay. Enric post. Okay. Here it will be, sir. Acha, this thing I'm deleting now. So name, change the name, sir. Enric post. The beauty of Enric post is, guys, it is having some similarity with that what is called in order traversal, sir. I want that result where I have that traversal, sir. Tree. Yeah. you see students, in order you visited D first, in post order also. Oh, that means at least up to reaching to that D, both the steps are same, na sir? Both the steps are same. Then what I will do here? Let me take the heading. Non-recursive post order traversal. Non-recursive post order traversal, sir. This is my tree, and I have the final answer also. This is the post order. This is what it will be coming as an output. This is what is going to come as output, sir. Okay. Now what we are going to do here, guys, very similar to in order traversal. This is not looking good. 1 minute. What is the final answer, sir? D array. D E B F G C A. This is my okay, sir. Now again, let us first go for the English like implementation. Then we will go for converting that English language to coding. Step number 1. Already I know that, sir. What do you know? Sir, first node visiting of in-order traversal, I found that it is same as that post-order traversal. So at least for that part, what I can say, sir, of course, here also initially PTR is assigned the address of root node. So like previous day, step 1, this one. One minute. Step 1, where is that? Yes. Initially, PTR is assigned the address of root node. Oh, that means simple. When I will call this function, I will pass root and I will capture it in PTR. Na sir? Yes. That already done in our coding also. In our coding also, that part already we have done it. Step 1 done. Where we have done this, sir? See, we call this function with what? Root. This root is captured where? Root is captured where? PTR. That means step number 1 done. Initially PTR is assigned the address of the root node. That part is done, sir. Super. Next, what I will do, sir, like previous, I will move along the leftmost path. Rooted or move along the leftmost path of a node pointed by PTR and pushing all nodes in this path onto the stack. When to stop? Sir, when I will reach to the leftmost node, that is not going to be pushed into the stack. So now PTR will be pointing to where? Leftmost node. So that means my step 2 is exactly same, sir. Step 2, no difference. Step 2, no difference. Step 2, no difference. Okay, so let us do that. This is my stack, sir. This is my stack. Move along the leftmost path at the node pointed by PTR. PTR is pointing currently where? It root here. Pushing all the nodes into the stack. That means will be pushed first? A. Next, who will be pushed? Sir, B. Next, will D be pushed or not? This says that stop when we reach the leftmost node. Currently leftmost node we reach D. Stop there. Leftmost node means which is no left child, and it is not pushed into the stack. So D is not going to be pushed into the stack. So currently where is the PTR, sir? PTR is pointing to here. PTR is pointing to here. Then what you will say? Sir, PTR has no right subtree or not? Currently PTR is having no right subtree. PTR is having no right subtree. So what we are going to do? Step 3 onwards, a little bit change will come. What change? Observe here. Step 3, what I'm going to do here. 1 minute, guys. Step 3. This is step 3, sir. In step 3, what I'm supposed to do? Sir, I will check if PTR has no right subtree. Guys, you remember one thing? Post-order traversal. Sir, first left subtree will be visited, then right subtree will be visited, then root will be visited. Remember that thing, na? I ask you to remember, but not to tell to anyone. Shortcut left, right, root. But actually, it's not like that, sir. It's actually left subtree of root, then right subtree of root. Sorry, left subtree of root, then right subtree of root, then root. And why I ask you to what to remember? Left, root, right. So currently, even you reach to D, you will not be able to say that I will be visited. For in-order traversal, you will say, okay, I will be visited. Because I will be visited, then only my right subtree will be visited. But in case of post-order traversal, no, sir. Left, right, root, na. It is not having left subtree. Okay, great. Does it mean that you will visit D? No, I cannot say that, sir. If its right subtree is not there, or if there, two cases can be possible. I ask, currently you are pointing to D. Does it mean you will visit D? No. Sir, already I know that its left subtree is not there. So then visit now. Why you are not visiting? Arey, how can I visit, sir? That is not the rule of post-order traversal. Post-order traversal means, sir, left part, right part, then root. Current root is what? D is current root, because that is where I am pointing. So left part not there. So visit. No, I have to check right part and then only. Are right part is also not there, then visit. Sir. If right part is not there, or if right part if there, if it is visited, na, then only I will visit D. So two cases can be there. Right part is not there, visit. So right part is there. And for B, its right part is not there. When will come? One day will come to B, na? Then B will definitely have the right part, na? So are you in a position to tell that, sir, visit B? No, 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 no. First check the right part is there or not there. Not there, then visit. There. If it is there, sir, first complete the right part, then I will visit. That is what I'm writing here. If PTR has no right subtree, great. If PTR has no right subtree, or its right subtree has been traversed, or its right subtree has been traversed, that means visited, has been traversed. Sir, its right part is traversed, sir. Then why you are waiting? What to do? Then visit the node. Then visit the node. If it is right subtree is not there, or its right subtree is visited, then visit the node. Then, sir, after that, what to do? Definitely you have to look towards the stack and pop another node from stack. Tell me, students, as per our example, currently where is PTR? D. PTR has no right subtree, na? Yes, no right subtree. Then what they're asking? Two part, or all part is not there, for at least for D, sir. This part only. No right subtree. Okay. Then visit the node. Which will be visited? D. See? D is there, na? Next, sir. Currently you are not having any other option other than looking towards the stack. Oh, I look towards the stack. Pop another node. Who will be popped? B will be popped. Who is going to pop? B is going to pop. Then PTR is pointing to where? Sir, PTR is pointing to B. Next, what I will do, sir? Same means, that story. Keep on popping and visiting until keep on popping and visiting till a node is popped that has a right subtree and which has not been traversed. Let me take this. Where is that line? Before that, this line will be there. If the stack becomes empty, then traversal is finished. Currently not empty. Now let me copy this. A little bit change will come. Sir, is the stack is empty? No. Still something is there in the stack. Now what they're asking? They're asking that keep on popping and visiting the nodes until a node is popped that has a right subtree. So currently you pop a node, which one? B. That is having a right subtree. That is having a right subtree. Okay, sir. So what I will do? Can you visit that B directly? PTR is pointing here. Can you visit that B? No, sir. Why? Sir, to visit B, its left subtree have to visit it, right subtree have to visit it, then only I can visit. Left subtree done, but right subtree is not done, na, sir. Then how can I visit? So that means, can I say now PTR is pointing to such a node which is having a untraversed right subtree? Yes, definitely. Definitely. So I can add this line here. I can say here, currently PTR points to a node that has an untraversed right subtree. Yes, it's correct. So what I have to do? Simple, sir. What in the previous algorithm you have done? In previous algorithm, what you have done? There you are telling visit the node pointed by PTR, and now assign the address of the right child of the node to PTR. Same thing we are going to do here. Visit the node pointed by PTR. No. Can I do the same thing, guys? No, you cannot do the same thing, because visit the node pointed by PTR means B will be visited, but I cannot visit B. Then what I have to do? Sir, first visit the right part. That means step number 4 will be a little bit different here. What is that? Step number 4, it will be a little bit different. What is that, sir? Now it is asking push the node pointed by PTR, because you are not able to visit that. You are not able to visit that. Can you visit B? No, I cannot visit that. If you are unable to visit that node, then where you will keep that node? Definitely you have to keep it in the stack. So push the node pointed by PTR, and now PTR is assigned the address of its right child. That means B's right child. And in the meantime, what we have done? Sir, I pushed that B again back to the stack. And where is PTR pointing, sir? PTR is pointing to now E. PTR is now pointing to where? E. Super. Next, what I will do? In the previous algorithm, go to step 2. Here also same. Go to step 2. Go back to step 2. Go to step 2. Let's come to step 2. Sir, how till now how many node visited? Only one, guys. No need to worry, sir. Remaining node also will be visited. Then again move along the leftmost path. Sir, I am already in such a node which is the leftmost. So any question of moving from here to the leftmost path? No. Any question of pushing anything to the stack? No. Then where PTR is pointing here. Now what I will check? Do you have any right subtree? No. Then can I visit you? Yes. Then who will be visited, sir? E will be visited. E will be visited. So D visited, guys, earlier. Currently E got visited. Super. Now B is smiling, guys. The node B is smiling. Why? Array, my left subtree visited, my right subtree also visited. Now you are having no option. Compulsory you have to visit me. Compulsory you have to visit me. Sir, where is that coding? Currently you are pointing PTR where? Sir, in E. PTR has no right subtree? Yes, no right subtree. Visit that, done. Pop another node from the stack. Who will be pop, guys? Sir, B will be pop. B will be pop. What to do? Stack becomes empty? No. Keep on popping and visiting the nodes until a node is popped that has a right subtree. Yes, I pop a node which is having a right subtree. Then PTR points to a node that has untraversed right subtree. Sir, earlier PTR was pointing to a node that has an untraversed right subtree. But currently PTR is pointing to a node that has having a right subtree. That is having a right subtree. Sorry, that is having a traversed right subtree. that is having a traverse right subtree. So now what I will do, sir? Achha, here I write PTR points to a node that has an untraversed right subtree. Na, sir, at that time it was having an untraversed right subtree, but this time it is having a traversed right subtree. So this line will not become that much meaningful. Only for first time it is meaningful, but next time onwards this line will not become meaningful. Why? Because now PTR is pointing to a node that has a traversed right subtree, because PTR is pointing to a B and which is having a right subtree in the form of E, which is already traversed. So I want to delete this line. Now what I will do? Push the node pointed by PTR, na? No. 1 minute. Because if I push it again, achha, let me, this one, just if I write this in English word, it is a bit problematic. Currently arranging it a bit difficult. Let me write the algorithm first and then I will come back to the English word, because whatever I'm trying to express, that will be better I will able to express in coding, and then I will arrange that in those English words. Okay, so algorithm Enric post. So what I am going to do, sir, first let us capture that root node in the PTR. Done. Then what I will do, sir, I will move along the leftmost path. Moving along the leftmost path means, and total thing, you know that like previous algorithm, I will keep it inside a infinite loop. If you are not understanding the infinite loop funda, later I will tell that. Then moving along the leftmost path means that same story. PTR arrow L child not is equal to null. If it is true, what I will do, sir, I will push it into the stack. So push PTR and then move PTR equal to PTR arrow L child. This is same, no changes is there. Okay. Now PTR is pointing to which node, sir? D. Super. Now what I will check? Whether D is having while PTR arrow R child equal to null or not. That means it is having an empty right subtree. If it is having an empty side right subtree, then visit it, sir. Or when to visit? PTR arrow R child will have a tree, will have a right subtree that is visited. But how do I know that it is visited or not? So let me do one thing. Let me write here one extra variable. I'm taking here q is equal to PTR. So initially what happened, guys? Initially PTR is having which node's address? A. So q is equal to PTR means currently q value becomes what, sir? Q value becomes A. So I'm checking here, is PTR or R child equal to null for D? Yes, it is null, and logical OR operator is there. Logical OR operator, this part I will fill up later. Logical OR operator is there. One part is true means I will entering in the loop. After entering in the loop, what I will do? I will visit that node. So that write PTR arrow data. That means who will be visited, guys? D will be visited. Write PTR arrow data. D will be visited. After visiting D, what I will check, sir? I will D visited na, guys. So initially I take that q to where? A. I want to update the q value. Q is equal to PTR. So that means my q value now got changed and it becomes D. Okay. Then I will check that if stack becomes empty or not. If top equal to -1, that is stack empty, nothing to do, return. Otherwise, sir, definitely I have to look into the stack and I have to pop an element. Okay. That is what PTR equal to pop. Done. This while loop ends here. Remaining story are same. Achha. After this, what I have done in our previous algorithm. Write PTR arrow data. This is where it will be changed, right? So let's see up to this what we have done. So this part executed, this while loop executed. Okay. Currently, who is there in my stack? currently who is there in my stack? A is there, A is there, then B is there, right? Next, what I'm checking here, PTR arrow R child, D arrow R child equal to null. Yes. What is there on the other half? I don't want to know. One part true means entirely true, right? PTR arrow data. That means D got visited. D got visited. Okay. Top equal to -1. No. PTR is equal to pop. Okay. Then who will be pop? Sir, B will be pop. But can I visit B directly, sir? Loop will come back. It will check B arrow R child equal to null. Is B right child is null? No. Or PTR arrow R child, is it visited or not? Visited means, is PTR arrow R child, is this value is visited or not? How do I know, sir? So currently PTR arrow R child is what? E, as per the diagram. But in my queue, what value is there? D. So I will check here, PTR arrow R child is equal to Q or not? Is equal to Q or not? Q indicates that what, guys? Q indicates that that node is visited. That is indicated by Q. Q indicates that the node is visited. Now what I'm checking, PTR arrow R child. What it means? Sir, PTR arrow R child means, you observe here, it is E. And what about your Q? Q is D. Are they same? Are they same? They are not same. That means this while loop is not entertained. What does it mean? Sir, for the node B, neither it is having an empty right subtree or its right subtree has not visited. First of all, it is not having empty right subtree, so that you can tell it will be visited. No. Or its right subtree is what? E. That is also not visited. So you can't say that I will visit B. What I have to do, I have to visit E and then I have to come back. So currently what I have to do, I just I just popped out that B from the stack, but I need to again push it in back into the stack. Why? Because I was unable to visit B. So that's why what I will do here, currently I was unable to enter into the loop. I will say push PTR. Push PTR. That means who will be pushed? B. Now I have to traverse the right subtree now. Then go to the right side. PTR equal to PTR arrow R child. Then where PTR is coming, sir? PTR is coming to E. Super. PTR is coming to E. Now my journey will start from E. Observe here. E. Sir, I came back to the infinite loop. This while loop will not entertain because currently I am in the leftmost node. So PTR is pointing to E. Now we are checking, is PTR arrow R child is equal to null? Yes, sir. E is not having any right subtree. E is not having any right subtree. Check it out. Not right subtree. Will I enter here, sir? Yes, I will enter. What he will do after entering? Sir, PTR arrow data. That means E. Visiting done. Then Q is equal to PTR. I told you now, guys. Q indicates what? The node which is visited. Just now we visited what? E. Then immediately what you are telling? Sir, Q is equal to E. Super. Q is equal to E. Is this stack is empty? Is this stack is empty? No, sir. Stack is not empty. Then PTR is equal to pop. Who will be pop? B will be pop. Now you see, when the loop will rotate, it is checking, is PTR arrow R child equal to null? No. B is not having empty right subtree, not there. Then his right subtree is visited. Yes, visited. Why? Sir, PTR arrow R child, B arrow R child. Check it out. What is that? E. And Q value. What is that Q value? E. Oh, its right child is visited. Nah, its right subtree is visited. So this condition is true. What will do? Sir, I will enter. Can I happily visit B now? Yes, I can visit B. Then what will be visited? B will be visited. Then I told you what? Q indicates what? The node that is visited. So that means Q will become what? B. Q will become what, sir? B. Next. Is this stack is empty? No. PTR equal to pop. Sir, who will be pop? A. A. Can you traverse A, guys? Sir, for to traverse A, na sir, its left subtree have to be visited. Are its left subtree is visited, na? DBE. DB, DBE, whatever, left subtree visited. Then visit, na? No, 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 sir. If A is not having right subtree or its right subtree is visited, then only I can visit A. Oh, so now once you come back to this loop, you are checking PTR arrow archild equal to null? No, not null, not null. This condition failure. You are coming here. PTR arrow archild equal to Q. Sir, PTR arrow archild is equal to Q means what? B. And PTR arrow archild is what? Remember, PTR is now A. PTR arrow archild is what? C. Are they same? No, they are not same. Then what you are doing? Sir, coming out of the loop. What thing to push? Sir, A got pushed again. A got pushed into the stack again because A cannot be traversed. Super. PTR equal to PTR arrow archild. Where PTR will come? Remember, C. Then what you will do? Sir, in that same infinite loop, na? Sir, towards left I will move. Towards left you will move. What I will push into the stack? Sir, C I will push, but F I will not push. Okay. Push your C here. But F, that is the leftmost, no, I will not push. Then PTR is pointing to where? Sir, PTR is pointing to F. Are you ready to visit F? Sir, F is not having left subtree. It is the leftmost node. Right subtree is not there. Yeah, I'm ready to visit F. Check it out. PTR arrow archild equal to null. Yes, null. Right PTR arrow data. Who will be visited, sir? F will be visited. F will be visited. Next, Q equal to PTR. That means you know that Q means, sir, the node that is just now visited. What is that? F. F. Next, top empty, no. PTR. Who will be pop? C. But can you visit C, guys? Sir, I have to check. Left subtree of C visited. Right subtree, oh, not visited. No, sir, I cannot visit. Where the condition will fail? C arrow archild equal to null? No. PTR arrow archild equal to Q? No. Because Q is what? F. PTR arrow archild is equal to what? G. Same? No. This loop entertained? No. Push. Oh, C got pushed again. PTR equal to PTR arrow archild. Where PTR will go? Sir, G. Remember, PT is where? G. Come back. Sir, already leftmost node. This loop will not entertain. Do it have the right subtree? No. Visit. Sir, who will be visited? G. G. Then, sir, Q is equal to PTR. So PTR value become G, sir. PTR value become G. Okay. Stack empty? No. PTR equal to pop. Now you are making a pop operation to C. Again you are checking. Can I now visit C? Earlier I tried, I failure. Now PTR is C. Remember, PTR is C. Now what you are checking? Oh, C. Your left subtree visited. Do you have null value? No. Right subtree? G. Check it out. PTR arrow archild. What is that? G. And Q value? G. Oh, visited, na sir. Right PTR arrow data. Now C is visited. Because it's left subtree visited, right subtree visited. What is the problem? Visit. C visited. And who will be getting the value of PTR? Q is getting the value. Then Q value will become what? C. Stack is empty. No, sir, not yet. PTR is equal to pop. Oh, A will be, pop out. Now what you will do? Sir, for A, I will check left subtree, right subtree. Left subtree is null? No, not null. Then come to other half. A arrow archild. C. Q. C. Array, sir, for A, left subtree visited. DBE. Check it out. DBE. Right subtree is visited. FGC. FGC. Visited, na? Now, happily, can I visit A, na, sir? Yes, I can visit A. Then what you will do? Write PTR arrow data. What will be visited? A will be visited. Stack is empty. Sir, stack empty. Return the control from here. Check it out. This is the thing you have now as a Postorder traversal. See these guys. DEB, DEB, FGCA. Only one difference is came, sir. Here, whenever the question of visiting a node comes, na, two things I have to check. Right subtree not there, I will be visited. Or if right subtree is there, is the right subtree is visited? If it is visited, then I will be visited. Then you can visit me. No, not visited. Then go to my right. Then how do you know that right subtree is visited or not? Sir, that's why I'm keeping a pointer here. Whenever a node is visited, na, I'm capturing that value. So that next time when the control will come back, I will be in a position to check both the part. Right part not there. Then happily I will enjoy like anything. I will be visited. No, right part is there. This condition is failure. Right part is there. Then what you are checking is the right part is previously visited. Are how do you know that previously visited or not? Are sir previously visited? Not only I'm keeping in queue now. That's it, guys. So just I have to arrange those English language a little bit. Algorithm point of view, it is okay, sir. I arranged perfectly and it's working. So just English language point of view, I have to arrange that last step. This one here, just I have to arrange the English words properly. That I will do tomorrow, guys. I will make a homework and I will arrange this sentence properly so that it will be easier for you to understand. And also tomorrow when I will go for implementing this in the program, one more time you will get the clarity. And by that our binary tree and binary search tree related all the algorithms will be done. Our next topic will start as binary search tree deletion. That may not start from tomorrow, or if it starts from tomorrow, it will be only one case, because after implementation of that program it will be, because binary search tree deletion is a big process, so there maybe only one case I may able to discuss tomorrow. Whatever, tomorrow we will have this session, so that I will discuss tomorrow. Thank you, guys.